Can you tell me the difference between the two ornaments on your screen? Yes, the one on your left shows variation in colors, while the one on the right is singly colored. To be precise, can we say that the first one is made up of repeating units which are different from each other? On the other hand, the second set has same units repeated several times to form the chain. But why are we discussing these ornaments while studying carbon chemistry? Well, that's because carbon exhibits properties just like one of these chains. That's correct. The chain with single colored pearls is what I'm talking about. As we can see here, all the pearls are of the same color and the same size. On similar lines, carbon atoms show a tendency to form long chains. This tendency of carbon atoms to bind with other carbon atoms, resulting in exceptionally long chains, is called as catenation. Wait a second. We know that there are many elements which have atoms bonding together. So why are we saying that carbon bonds uniquely and it exhibits catenation? We have come across similar atoms forming bonds. But how long will the chain be? A few atoms long, that's right. However, carbon chains are very long. When I say several atoms bond together, I literally mean several atoms. Yes, hundreds of atoms of carbon form bonds with each other and give rise to huge chains. Now the next question to pop up in our minds is whether carbon atoms have a single, a double, or a triple covalent bond between them. What could be the answer? Well, needless to say, it can form all these types of bonds. Now let's see how these bonds are formed. If we have one electron pair shared between the two carbon atoms, then a single covalent bond is formed as seen here. In this case, both the carbon atoms can bind with different atoms like hydrogen or oxygen to form bonds. This is what we normally see in many compounds. Another possibility is that the two carbon atoms can bond with other carbon atoms, giving rise to side chains. Such compounds where all carbon atoms share a single covalent bond between them are called saturated compounds. So what will be the other types of compounds? That's right, the ones having at least one double or triple covalent bond between the carbon atoms. If there is a double covalent bond between the two carbon atoms, then that gives rise to 2 electrons left with each carbon atom. Similar to the saturated chains seen a while ago, in this case as well, each carbon atom can again form 2 bonds with other elements. Also, bonds can be formed with more carbon atoms to give side chains. Another case is where the 2 carbon atoms share 3 pairs, that is 6 electrons. In such a case of triple covalent bond, each carbon atom is available only for a single bond formation with other atoms. Such compounds where we find at least one double or triple covalent bond between carbon atoms are called as unsaturated compounds. The property of catenation gives carbon an exceptional capacity to form a variety of compounds. The huge chains which are formed with branching are all because of catenation seen in carbon. Now that we've understood the reasons as to why and how carbon forms numerous compounds, let us talk about these compounds in detail. Let's begin with understanding saturated and unsaturated compounds in the next video.